हरि करना।
Welcome to the second part of fifth module, that is everything about Maven. So here Maven is a build tool. So we are going to discuss about how to build a source code into an artifact. So everything about Maven and what all steps will be there in the building process. So we are going to see, as the title of this slide says, everything about Maven. That's what we are going to look. So first, let's understand what really is a build process. Maven is a build tool. So when you say Maven is a build tool, so what is that adjective build here? So what does it mean? So what really a build is? So let's begin to look into what is a build process. So a build process starts with a source code. What is source code then? Source code is the list of human readable instructions that a programmer writes, often in a word processing program, when he is developing a program. So source code and object code are the before and after states of a computer program that is compiled. So programming languages that compile their code include C, C++, Delphi, Swift, Fortran, Haskell, Pascal, and many others. So let's look into one of the example of Java source code. You can see that this is how it looks like. Example, you want to have a digit button text. So string digit button text. So if you give information like this 7, 8, 9, so you will get the digit button. Then if you want an operating button, so this is what. And if you want a memory button, so you mention this way. And string special button, so backspace cce. So this is how the Java source code looks like. This is called a source code. Similarly, you might have seen Python source code. If you have done engineering, you might have seen C source code. Okay. So so once your source code is ready, so now you have to go for the compile process. So the source code is run through a compiler to turn it into machine code, also called object code, that a computer can understand and execute. Object code consists of primarily ones and zeros, so it isn't a human readable code. So a compiler is a software that converts the source code to the object code, source code to the machine code. In other words, we can say that it converts the high level language to machine language. Moreover, it is necessary to perform this step to make the program executable. So this is because the computer understands only binary language. So some compilers convert the high level language to an assembly language as an intermediate step, whereas some others convert it directly to machine code. So this process of converting source code into machine code is called compilation. So let's look into the compilation more detail as we go through this, as we move ahead in this module. So, but some of the example that we can see, the compilation, the compilers extensions are Java C is a compiler extension for Java. PYC is a compiler extension code for the Python, and ROSYLC and many more you can find out. So PYC, at least .pyc is the compiler you might have seen in your life. So then once the code is being compiled, so next we will go for the tests. So unit tests are conducted by developers and test the unit of code, a module or component. So basically they'll test the unit of whole code. Unit of whole code, what is the unit of whole code? It could be a module or some component, specific component. So it is a testing method by which individual units of source code are tested to determine if they are ready to use. So it helps to reduce the cost of bug fixes, since the bugs are identified during the early phases of the development life cycle. And integration testing is executed by testers and tests integration between software modules. It is a software testing technique where individual units of a program are combined and tested as a group. Test stubs and test drivers are used to assist in integration testing. Integration test is performed in two ways. So one is the bottom up method and second one is top down method. So unit testing test each part of the program and shows that the individual parts are correct, whereas integration testing combines different modules in the application and test as a group to see they are working fine. Unit testing starts with a module specification, while integration testing starts with the interface specification. Unit testing can be performed by any time. On the other hand, integration testing is performed after unit testing and before system testing. Unit testing is executed by the developer, whereas integration testing is performed by the testing team. So unit testing errors can be found easily, whereas in integration testing it's difficult to find errors. So unit testing is a kind of white box testing, whereas integration testing is a kind of black box testing. So the best examples for unit testing tools or unit testing or integration testing tools are PyTest for Python, heavily we used for the Python code, and Selenium. It's widely used for it's like multi-purpose tool, and Nose2 rational integration tester, protractor, and so on. So once the source code has been compiled and then tested, unit tested and integrated integration tested, so now it's time for package. So a software package is a collection of system resources that are packed together. So these packages enable the end user to perform some types of tasks when the software package gets deployed or moved across various servers and installed on their device. A software package could come in multiple formats. It could be .exe and MSI. So exe and MSI being the most common ones used by independent software vendors. Normally, in short, we say ISV, independent independent software vendors all over the world. And also JAR, JAR is widely used for Java based applications, and JIP is for the general purpose applications. So once your source code has been compiled and tested for unit testing and then integration testing, now it's up, and once testing is done, then you'll go for the packaging. Once packaging also has been done, now it's time for health checkups. So can we ever imagine sitting back and manually reading each line of code to find flaws? To ease our work, several types of static analysis tools are available in the market. So, which helps to analyze the code during the development and detect fatal defects early in the software development life cycle phase. So, such defects can be eliminated before the code is actually pushed for functional quality assurance. A defect found later is always expensive to fix. So, most modern software intensive organizations deploy Code analysis tools in their development and quality assurance cycle. This is a relatively new phenomenon in the last several years as code bases have gotten more complex. So, quality assurance has become more sophisticated, and organizations have understood that testing is too expensive and insufficient to prevent errors from getting into live systems. So most code analysis tools in the market today are deployed by individual developers. So sometimes with the minimal management, so involvement, minimal management involvement. So some project managers and architects aggregate the results coming from code analysis tools into team level dashboards. So to put everything, to sum up in a nutshell, well, developers write the code. We call this a simply a source code here. So you can see that the first step of this complete flow. Okay, the first step, developers write the code. We call this simply source code. They are creating a product like a web application or a mobile app, anything that is a source code. So they keep committing the changes to the source code, and while they commit the change, they would like to test it. So they will compile the code, and this especially for the compiled languages like Java, .NET, C, like that. So they will compile it and compile the code, then they test it. So if it works as per their wish, then they will package it. So after the testing, if it works as per their wish, they will package it. So compile process is going to generate some files, the output files that they package it into an archive. The files that were generated from the compile process will be tested, and after that these files which were generated from the compile process will be packaged, and we call that as an archive. So a source code is generated or changed programming languages like Java or .NET. So then the compile process will compile it. So once the code has been compiled, if it's a Java code, then the compiler like Java C will be used. The extension, after the compiling, the extension will become a .java. So when it is compiled, the Java C compiles it then it's going to generate class files. There will be unit test or integration test, so that this unit test or the test written by the developers to test their own code. So this is, and you don't confuse with uh, this unit testing or integration testing with the software testing. That's a completely different process, and it happens in a different level. That also we are going to see, but this is completely a different activity that we are doing. This is not the software testing. So a unit of code will be tested by a unit test. That's it. A small module of code, a piece of code will be tested by a unit test. So if that works fine, then the class files will be packaged. So now based on what the target is, like if it is a software for Windows machine, then there will be a .exe or .msi format of packaging or archiving. So .exe, .msi, these are the archives methods of extension. .jar, .var is for Java. So if a Java web application mostly packages in war format, or other languages like Python, Ruby, other interpreted language will be simply archived into zip format or a tarball. So then also, if there is the step done by the developer of health check, that will be performed by the developer. So health check or code analysis. Health check is nothing but a code analysis. So this process is going to find any upcoming bugs or security vulnerabilities. Two things are very important. One is upcoming bugs, one is bugs, and second one is vulnerability. What is vulnerability? I'll tell you. In our we have some specific modules for this bugs and modules. There we are going to discuss in the code. So in short, this is the entire build process. Now there is a lot of steps. So developers, along with the writing their code, regularly committing their code, they also need to regularly do this build process, which is too much work if they have to do it very regularly.